Alrighty, so this is the second, I guess the second lesson walkthrough that I've done now with me being out this week, and this is an important one. So if you'll notice, this sheet we're going to start with, this is a review for the most part from multiplying polynomials. Okay, today we're not adding any polynomials. We're strictly doing multiplication with this, and then you'll notice the other sheet you picked up was actually lesson 3. So while I'm gone, we're starting the third lesson. Okay, very important lesson, very good lesson. I think you'll do fine with it. But, excuse me, let's go ahead and start with a review over multiplication. Okay, so if you'll notice, this just says find each product. Now, remember, product just means multiplication. Now, 4, 5, and 6 are very easy, right? What is 32 squared? Well, 32 squared is just 32 times 32, right? Well, you can use your calculator to find that. I'm not going to give you the answer to 4, 5, and 6. That's just very straightforward. Throw that in the calculator, and you're good to go. They'll be fairly big numbers. I mean, 32 times 32 is pretty big. But yeah, so you'll do that. Now, what I do want to do, though, is go back through these. Now, here is a mistake I see students make all the time. And I forgot to mention this in the last video. What I want you to realize, this does not mean, okay, we see how this is x plus 4 squared. This does not mean the answer is x squared plus 4 squared. Okay, that is not the reason. Do not just simply apply the exponent. Well, don't apply the exponent to everything in the parentheses. That is not what you would do. That'd be really bad. Okay, that's against the mathematical rules. You can't do that. Instead, what it means is, think back to the other day. We said that x squared rewritten is simply just x times x. Well, if you notice, this whole thing is inside a set of parentheses, meaning this exponent of 2 applies to the whole thing. So, excuse me, x plus 4, parentheses, squared really means x plus 4 times itself. So the whole thing, x plus 4, is times itself, x plus 4. That's what that means. Okay, it is not x squared plus 4 squared. That is incorrect. We can't do that. But this is really what it means. So we'll multiply this out. What method are we going to use? What's it called again? It's called the FOIL method. Okay, remember that. Or you could use the table method also if you want it. You don't have to. My examples will be using the FOIL method, but if you like the table method, by all means do that. Okay, FOIL method means first outer, so we'll distribute this x. So x times x is what? Is x squared. Alright, then x times 4. Okay, we get plus 4x. Okay, good stuff. Now, x times 4, or 4 times x rather. So again, we get plus 4x. And if you'll notice, these two middle terms are the same, right? That's going to happen every time you have a whole quantity squared. And now lastly, 4 times 4. Well, 4 times 4 is 16. Alright, then lastly, to answer this question, we don't want to leave it like that. The answer is going to be x squared plus, combined like terms, we get 8x plus 16. And that is our answer. Alright. So you'll do number 2 and number 3. You'll do it the same way. You'll rewrite it out. You'll say, okay, well, 2x minus 3 quantity squared is the same as rewriting it as such. Okay, this does not equal 2x squared minus 3 squared. This does not equal that. Okay, this is what it is, so you have to multiply it out. Alright, so you'll do that on this paper, on this part. Now, this is something I want us to notice. If I go back up here for just a second, like this x plus 4 times x plus 4, you'll notice it's literally the same thing, right? The signs are the same and everything. And we ended up with this where we could combine our middle terms and get this term right, or get this expression right here. Well, what's different about that with this one? Well, it looks almost like it's close to looking like the same thing. It's x plus 7 times what? X minus 7. Alright, let's work through this one together using the FOIL method, and you're going to notice something very interesting happen. Alright, so let's FOIL. So we'll distribute the x first. So x times x is going to be what? We get x squared. Then x times negative 7. Alright, that is minus 7x. Okay, because it's negative. Now we have positive 7 times x. Alright, so 7 times x is going to be positive 7x, so plus 7x. you're probably noticing something here, negative 7x plus 7x. We'll talk about it in a second. 7 times negative 7. Well, that's negative, and it's negative 49. All right, so whenever, okay, anytime you have this situation where you have the same number here, so x and x, then you have the same number here, so 7 and 7, except the terms inside are flipped. There's a plus 7 and a minus 7. The two middle terms are going to cancel out. Because what is negative 7 plus 7? It's 0, right? So it cancels out. And all you're left with is the outside terms. So this becomes x squared minus 49. And that is our answer. Okay, so similar to this, except now our answer only has two terms in it because the two middle terms canceled out. They beat each other up and they're gone. Okay, and that'll happen every single time as long as the first term in each match and the second term matches, but the middle signs are different. Okay, it's really cool. It's called the difference of two squares. And it's something we'll talk more about in depth in a couple weeks also. All right. We have 3x plus 4 times 3x, minus 4. Is that similar to this? Yeah, look at that. Our first terms match and our last terms match. But what's different? Yeah, the signs inside are different, right? So let's see if the same thing's going to happen. Spoiler alert, it will happen. The same thing will definitely happen. Okay, so let's use the FOIL method. So 3x times 3x. Now please remember, that is not just 9x. Okay, it is 9x squared. Okay, because we're multiplying the x with the x. Now 3 times negative 4. Okay, well 3x times negative 4 is going to be negative 12x. And now we're about to see why these cancel out again. So we foiled this one, so let's foil this one. 4 times 3x, because it's positive, right? So it's going to be plus 12x. Okay, we see it's about to happen there. And then 4 times negative 4. Okay, another thing is your last term will always be negative because it's a positive times a negative. So it's going to be minus 16. So again, what happens to these two terms? What is negative 12x plus 12x? Well, they cancel out, right? So we are left with 9x squared minus 16. Now, the reason that is significant is it can save you some time to notice that. Because the two middle terms will always cancel out, there's actually not really a point in doing that multiplication. Look, is it going to work that way with this one too? Let's see, the first terms match, okay, 5y and 5y. The second terms match 1 and 1, but the signs inside are different. So that means this is going to happen again. The canceling out is going to happen. So to shortcut that, all you have to do is multiply the first term with the first term and the second term with the second term. You with me on that? Because if you were to multiply this and this, then you would get two middle terms that you would already cancel out. So instead of having to worry about canceling anything out like this previous example, let's just simply multiply the first two terms and then the last two terms. If we do all that middle multiplication, it's going to cancel out anyways. So what's 5y times 5y? Well, 5 times 5 is 25, and y times y is y squared. Lastly, what is negative 1 times 1? Well, it's going to be negative 1. And now we're left with a polynomial with two terms, a binomial, just like we were with these two answers also. So I don't want you to think that's always going to happen, but it will always happen if your two terms in the front match, your two terms in the back match, and then your signs in the middle are flipped. Okay, this will happen 100% of the time if that's the case. All right, so let's see. This is going to be on you. It's a thoughtful question. I really want you to think about it. It's asking why is the middle term 2ab when you distribute out, and negative 2ab when you do it this way. So what you'll do is you have two situations. You have first situation, second situation. It wants you to multiply a plus b times a plus b and see what you get. Then it wants you to multiply a minus b excuse me, times a minus b, because it says a plus b squared, so remember you have to write it out like that and multiply it. Now, this is interesting. We see the shaded area and then a lightened area. This question wants us to find what is the shaded area here. Okay, the area of the shaded area here is what you have to find. I'll go ahead and kind of tell you how to set it up. Pretty much you're going to take x plus 7 times x plus 7, and whatever that equals, okay, then you have to find x minus 2 times x minus 2 and get what that equals. Okay, whatever this equals, subtract this from that, because this is the area of the entire thing, and this is the area of this piece right here. So if you subtract this from the entire area, you would get the area simply of just the shaded part. Okay, so go ahead and do that. Alright, now we're going to spend a little time going over lesson 3. Okay, lesson 3 is super important. It's called factoring. Now, I know everyone that is listening to this right now, everyone in my class, has done factoring before, but not to the extent that we're going to do it now. So, what is a factor? Okay, what is a factor? Well, a factor is a value that can multiply into another value. Alright, and so that's a kind of weird way of saying, like, okay, what are the factors of 6? Okay, now a factor has to be something that can multiply into another number. So, for example, 5 is not a factor of 6, because 5 can't multiply with another whole number to get 6. 5 plus 1 equals 6, but we're talking about multiplication here, so this would not work. Well, what two things can multiply to give you 6? Well, there's a couple. For this example, we could say 2 and 3 are factors of 6, because what is 2 times 3? Well, it's 6, right? Yeah. Now, a way to find factors of a number are by using something called a factor tree. A factor tree is this right here. If I were to write 6 and then put 2 lines going out, I want to think of numbers, so I'm going to start with the number 1 and say, is there anything with 1 that can multiply to give me 6? Well, yeah, what's 1 times what? It gives you 6. Well, it's 6. So here's a factor pair right here. 1 times 6 is 6.
Can I see Bryce West and Mateo Williams in the cafeteria, please?
Alright, and so let's go up to 2 now. Alright, so can 2 multiply with something to get 6? Yeah, we just said it. 2 times 3 is 6. Well, next number in line would be 3, but we've already used it. Well, then after that is 4. Can 4 multiply to become 6? Not with another whole number, so we're not going to use that. And we just said 5 can't multiply to be 6. Then we come back around to 6. So we're out of factors. So what that means now is that 6 has 2 sets of factors. 1 times 6 and 2 times 3. Does that make sense? So what we're essentially doing is we're working backwards. We're starting with the number and finding out what numbers can multiply to give us the starting number. So let's factor a few numbers here. So let's factor 25 by using a factor tree. Alright, let's start with the number 1. What can 1 multiply with to give you 25? Well, 25, right? So what this means is that 1 and the number itself will always be factors. So 1 times 25, it's a set of factors. Now 2 can't work. Could 3 work? No. Could 4 work? No, 4 can't work. Because a way to find that out, if you're trying to figure out if something's a factor, just take your calculator and go to the calculator and type in. So like if you wanted to know if 4 was a factor of 25, which it's not, but if you wanted to know it, you would just type in 25 and divide it by whatever you're trying to factor it with. No, so 4, okay, 4 is not a whole number factor. Now 5 is, though. What can 5 multiply with to give you 25? Well, 5. Now there's nothing else for 25 that'll work. So 25 also has 2 factors, or 2 sets of factors. 1 and 25, and then 5 times 5. Alright, so some of them have quite a few more factors. The number 30 has quite a few factors. If I were to split this out, I'm going to try and write a little bit smaller. Remember, 1 and 30 will always work, because 1 times 30 is 30. Now, the number 2 works because 30 is even. Okay, any even number has a factor of 2. Any odd number, like 25, does not. So 2 times what gives you 30? Well, 2 times 15, right? And like I said earlier, if you want to find out what the other number is that goes with it, if you can't remember, just go to the calculator and type in 30 divided by 2. It'll give you 15. So that means 2 and 15 are factors of 30. All right, is 3 a factor of 30? Oh yeah. 3 times what? Well, 3 times 10. Now what about 4? Now 4 is not going to work. 5? 5 will definitely work. 5 will work because it ends with a 0. So 5 times 6 is definitely a factor. So we keep going. Well, we've already used 6, so we're not going to use it on the left side. 7 doesn't work. 8 doesn't work. 9, 10, we've already used 10. So we're back around to what we've used already. So these are all the factors of 30. So 30 has quite a few factors. Not like a crazy amount, but it's got 4 sets of factors. Alrighty. Now 48x. Okay, so this is where it starts to get a little bit more of like the new stuff right here. Well, 48 itself has a lot of factors. So let's go ahead and let's ignore the x for a second and just talk about 48. Well, like we always talked about, 1 and 48 work as factors. Okay, 2 and 24. Can 3 work for 48? Yeah, 3 can definitely work. 3 and 16, right? Again, just take your calculator and do 48 divided by 3, and it will give you 16. What about 4? Yep, 4 and 12. Okay, 5 definitely can't work. Could 6 work? What do you think? Yeah, I'm going to kind of come over here to this side now. I'm going to start a new row because I'm out of room. So 6 times 8, right? Now 7 can't work. Okay, and 8 can work, but we've already used 8, so we're coming back around to what we've used. So we are now out of factors. Okay, and I know I'm doing this, but I like to kind of keep all my factors separated like that. Now, I left this blank space right here because what is something we haven't mentioned yet? We haven't mentioned the x, right? Because x is multiplied into 48x. Now, the reason I'm keeping x kind of over here by itself is because you could just put x with any of these numbers. If you want to factor 48x into 6 times 8, you could put the x with the 6 or put it with the 8. Because think about, what is 6 times 8x? Well, it's 48x, isn't it? Or if you did 6x times 8, if you just change where the x was, that still gives you 48x. So x is also a factor because it's included in the number itself. All right, then 1. Threw this on here just as a little think question. Well, 1 only has one factor, and it's 1. 1 times 1. Okay, so let's keep it going. All right, so here's where the kind of the reason we're learning about it now. We have 7x plus 28. All right, 7x plus 28. What we want to do is we want to find a common factor. Now, a common factor. Let's go ahead and write that phrase: common factor. A common factor is a number that factors into both numbers that we have here. So 7, let's think about 7. The only factors 7 has, I'm going to write it right here. The only factor 7 has is 1 and 7. Okay, those are its only factors. But what about the number 28? Well, let's think about 28. We have 1 and 28. We have 2 and 14. We don't have 3. We don't have 4, 5, 6. So we do have 7, right? 7 times 4 is 28. So do you see how 7 and 28 share a common factor of 7? So what we're going to do is we're going to, what we call factor out. We're going to factor out a 7, meaning we're going to divide both of these by 7. So what is 7x divided by 7? Well, 7x divided by 7 is just x. Okay, plus what is 28 divided by 7? You can use your calculator if you need. 28 divided by 7 is 4. Now hold on. We can't just leave it like that and call it good. We don't want to change anything necessarily. We can't just make that 7 disappear. So we factor the 7 out, meaning we divided this whole thing by 7 to get this. So what we need to do is rewrite this as a distribution problem and put 7 right here. So this means 7 times x plus 4 is the same thing as 7x plus 28. And let's check that. How could we check that? Well, we could check it by distributing back out. What is 7 times x? Well, it's 7x, right? And then what is 7 times 4? Well, it's plus 28. Did we end back up with the same thing we started with? Yeah, that's the whole goal. So what we're trying to do here is we're trying to take an expression like this and turn it back into its distribution form like we just did right here. So let's try another one. Let's have to think about this one. All right, so we want to find a common factor. All right, so a common factor between 5 and 25. Well, what are the factors of 5? Well, the factors of 5 are only 1 and 5. And now the factors of 25 are 1 and 25, but also 5 and 5. So there's our common factor. 5 is our common factor. But hold on. What else is multiplied in with both of these terms? They both have an x, right? This one has an x squared, and this has an x. So both of these have an x term with them also. So what that means is the common factor, I'm going to call it the CF, the common factor is 5x. Does that make sense? So this 5x squared, to multiply to get it, you can multiply 5 into it and an x into it. Same with this negative 25x. It has an x and a 5 is multiplied into it. So what we're going to do is we're going to, like what we said earlier, we're going to factor out a 5x. So I'm going to go ahead and write the number we just factored out. We factored out 5x, okay, and we're going to turn this into a distribution. So we factored out 5x. So what is 5x squared divided by 5x? Well, let's just do it with the coefficients first. What's 5 divided by 5? Well, it's 1, right? Well, okay, so it's 1. And then what is x squared divided by x? Well, remember, when you divide with the same base, you're going to subtract your exponents. So 2 minus 1 is 1. So really, when we factor out a 5x from x squared, we're left with 1x, which I'm just going to call it x. Okay? Minus, because of the minus sign, what is 25x divided by 5x? Well, let's do the coefficients first. What's 25 divided by 5? Well, it's 5. And then what is x divided by x? Well, that simply just makes it go away. So there we go. This right here, 5x times x minus 5, is the factored, we call it the factorization, or the factored form of this expression right here. And the way to check if you're correct is you can distribute this back out. And when you distribute this 5x, you should end up with the same thing you started with. So what is 5x times x? Well, that is 5x squared. Then 5x times negative 5? Well, that is negative 25x. And this is the same thing as what we started with. All right. So here's where it starts to get just a little bit tougher. This question is asking, here's kind of a new term, what is the greatest common factor, abbreviated GCF? Now the greatest common factor is simply the same thing as a common factor like we found up here, except the word greatest means biggest. So it's really asking, what is the biggest number we can factor out of this expression here? So the way to do that is look for the smallest number. Okay, and don't look at the signs either. Just look for which of these coefficients would be smallest. Well, it is this 6 right here. And let's factor the 6 out. Well, 6 can factor into 1 times 6 or 2 times 3. Those are its only sets of factors. Okay. Now we want to look at these other two terms. Can any of these factors factor into these? Can a 6 factor into an 8? No, because 6 can never multiply to become 8 with a whole number. Neither could 3. Now 6 and 3 could work for 12, but it has to work for all 3 of these. So it's looking like the biggest number that can factor out is going to be a 2. Because what is 8 divided by 2? Well, it's 4. What is 12 divided by 2? It's 6. Okay, so when we factor out a 2, then we'll be factoring the greatest common factor, which is the biggest thing that can factor out of all these. Now pause. What else do all of these have? They all have some form of an x. Now again, let's go to the smallest one, and that is this again. See how this is an x to the third power? That means we can't factor out anything bigger than that. But x to the fourth power is bigger than x to the third, and x to the fifth power is bigger than x to the third. So we can factor out x to the third power from everything also. So we're going to factor out 2x to the third power. Okay, 2x to the third power is going to be our greatest common factor. 2x to the third power. And now remember, we're factoring this into a distribution problem. So now what we're going to do is we're going to take this right here, and we're going to divide 2x to the third out of all of these. So we have 12x to the fifth power divided by 2x to the third power. So let's just do it a step at a time. What is 12 divided by 2? Well, it's 6. And then what is x to the fifth divided by x to the third? Remember, when we divide, we're going to subtract them. So 5 minus 3 is 2. So we get 6x to the second power. All right. Now let's factor a 2x to the third power out of 8x to the fourth. So what is 8 divided by 2? Well, we get 4. And then x to the fourth power divided by x to the third power. Well, that's simply just x. It's x to the first power, but you don't have to put that exponent of 1. Now, 6x to the third power, factoring this out, 6 divided by 2 is going to be 3. And remember the minus sign right here. So minus 3. And now x to the third power divided by x to the third power makes the x go away. So we just get minus 3. And here is our answer right here. Now the directions below it say, now rewrite the polynomial in distribution, like as a distribution problem. But that's what we just did. This is a distribution problem now. We made it 2x to the third power times 6x to the second power plus 4x minus 3. So do we see how this is now a distribution problem? And now what would happen if we were to distribute this back out? Well, we would get what we started with. I've kind of written all over it, but we would come back to what we started with, and I'm going to show you that real quick. So 2x to the third power times 6x to the second power. Well, 2 times 6 is 12, and x to the third times x to the second power is x to the fifth power. All right, 2x to the third times 4x. Well, 2 times 4 is 8. Okay, x to the third times x, which is actually x to the first, gives you x to the fourth. So far it's looking like it's matched up. Okay, minus 2x to the third times 3. Well, 2 times 3 we get 6, and then it remains x to the third. Well, that is what we started with up here. Okay, I know this is kind of a new thing. It might be a little tough, might be a little intimidating, but it just takes some practice. And so now let's go to the back, and we're going to do a couple of these together. Then it's going to be your job to do the rest of them. So there's 6 examples here. I really want you to try and really try and see if you can get to all these. All right, so let's look at this one first. So negative 12x to the third power plus 18x squared minus 27x. Now, real quick, do these all have an x? These all share an x, right? How much can we factor an x out? Yeah, we can go ahead and factor an x out. So I'm just going to put the x right here. Now, we can't factor x squared out because this does not have an x squared. The most we can factor out is just the lowest x value, which is this x right here. Okay, now let's look at these numbers. Where's the smallest number at? Well, it's this 12 right here. Okay, so let's factor 12. I'm going to do it above because I already wrote this x right here. Well, we know that 1 and 12 will work. We know that 2 and 6 will work. And then what's another factor of 12? 3 and 4 are factors of 12. Okay, and those are all the factors. Okay, what about 18 and 27? Which of these will work? Can 6 work for both of them? Now, 6 could work for 18. 18 divided by 6 is 3. 6 cannot work for 27. Neither can 2 because 27 is odd. 4 can't work because 27 is odd. 3 can work. Okay, 3 is going to be our other factor. So we're factoring out an x, and we're factoring out a 3. So we're going to factor out 3x. Okay, remember we're going to turn it into a distribution problem. So it means we're going to divide all 3 of these things by 3x. So negative 12, so I'm going to go ahead and put my negative. What is 12 divided by 3? It's 4. Okay, and then x to the third power divided by x. So x squared. Okay, plus 18 divided by 3. It's going to be 6. And then x squared divided by x. Well, it's just going to be x, right? And then negative 27, so minus 27 divided by 3. It's going to be 9. Okay, and then x divided by x. Well, the x goes away, and we're left with this right here. So this is the factored form. As a reminder, that's what we would call it. It is the factored form of this expression. So this and this, those are the same thing. Those are not different expressions. They're the same thing. All that needs to happen is I can distribute this number back out. I can distribute this 3x out, and we'll end up with the same thing we started with. That's what that means. All right, let's do one more, and we're gonna do letter C. So first thing, let's just look at the variables. Do they all share the same variable? Yeah, y to the 6th, y to the 4th, and y to the 3rd. Well, the lowest y exponent is with a 3, so that means we can factor out a y to the 3rd power. Okay, because if you factor out a y to the 3rd power, it'll go away here. You can 3 is less than 4 here, and 3 is less than 6 here, so that's good. Now, where's the smallest number? Well, it's the 16 right here. So I'm going to go ahead and factor it. I'm going to factor it upwards because I already wrote my y right here. So 1 and 16 work. 2 and 8. Does 3 work? No, 3 don't work. 4 does. 4 times 4. All right, and that's going to be all the factorizations of 16. Just these 3 sets of factors right here. All right, so now we have to look at the rest of these and ask which one is going to work for all these. Will 8 work for all these? No, 8 can't work because of that 20 right there. 20 can't be divided by 8 evenly. So I think it's going to have to be 4. Okay, 28 and 20 and 16 can all be evenly divided by 4. So we're factoring out a y to the 3rd power and a 4. So we're going to factor out 4y to the 3rd power. Okay, so negative 16 divided by 4 is 4. Then y to the 6th power divided by y to the 3rd power. Well, remember, subtract your exponents since we're dividing. That's going to be y to the 3rd power. Okay, plus 28 divided by 4. You get 7. Then y to the 4th power divided by y to the 3rd. Well, we get y to the 1st power because 4 minus 3 is 1. You can simply just leave it y because there's an assumed 1 right there. And then lastly, we get minus 20 over 4. 20 divided by 4 is 5. Then y to the 3rd divided by y to the 3rd cancels it out. And there we go. We're left with that. This right here is the same as what we started with. It's just what we call the factored form. Okay, and you could check that too. So on the next 4 that you're going to do without me, a good way to check your work is to just multiply back out. So you could distribute this number back out to everything, and it should give you the same number. I'm not going to do it on this one, but it will give you the same number. All right. So as usual, if you have any questions, please feel free to let me know. Try and get as much of this completed as you can. If you can get all of it completed, that would be fantastic. And if you have any questions, feel free to email me, or you can look at that document that I made and put it in Google Classroom. It has how-to videos, so if my video didn't explain it well enough, there's videos on there that will also explain it too. All right, y'all have a great day.